Very good afternoon to all member participants from various institutions. I welcome you all for the today's parallel subsequent lecture series. So here, under latest research trends in mechanical engineering, today we are going to have the topic on study and analysis of single and multi-robot work cell through by means of a case study. We are going to discuss both the features of single and multi-robot work cell layout in assembly shop floor system. So before moving to the main subject presentation, let us go with the session objectives. The main core objective of using the work cell inside the factory shop floor is to improve the safety of the job operation by maximizing the higher productivity, maintaining high consistency for each set of the production operation by minimizing the labor cost with the aid of the automation technologies. Now let us go with the core theme of the presentation. Before moving to the different types of work cell layouts, so I would like to give a simple understanding about what do you mean by a robotic work cell layout, how that will be uh, illustrated graphically. So based on the graphical illustration, so I can refer to that and say that work cell is nothing but a closed cabin or a closed fencing. Inside that, a lot of automation equipments like automatic conveyor, pallet mover, pick and place arm type robot assembly, everything can be fixed in a particular area in order to perform the intended task according to the sequential plan of assembly operation. Now coming back to the subject presentation, single and multi-robot work cell in both the type of layout, the common objective is to control the station time, that is the work completion time. So we have to optimize the work completion time by sequencing all the batch of jobs according to the flow of pattern. For doing so, we have various standalone simulation softwares to perform all various kind of virtual testing and analysis in order to reduce the cycle time constraints and also other challenge the case studies through simulation we can able to solve it very easily. What are some of the common key strategies for cycle time optimization? Improving the layout as well as the, the spatial design of each and every equipments that are supposed to be mounted inside the layout. Next one is trajectory optimization. Study and analyze the most simplest possible motion of the robot arm inside the work cell so that it has to move freely for performing various pick and place type of task activities. Next one is performing the task scheduling operation, then equally balancing the workload inside the layout, then doing simulation and offline programming in order to calculate the cycle time constraint without disturbing the regular production. Now let us see the common characteristics of single robot and multi-robot work cell optimization. First, let us go with the type 1 single robot work cell optimization. By using the basic the kinematic, the motion path planner option, we can able to identify the best robot type of configuration that can be utilized for a specific the production job operation. Accordingly, we can able to find out the possibilities of motion reduction by aiming for reduced travel distance between the two nodal points. The next one is the multi-robot work cell optimization. So here one can aim for collision avoidance. So prepare a plan in such a way that we can prevent the collision by minimizing the waiting time between the two parallel robot workstations. At the same time, we can utilize both sequential and parallel processing of work activities in order to manage and synchronize the group of multiple the robot assembly unit. Then using standardized scheduling algorithms in order to prioritize the job batches according to the due date constraints. What are the common mistakes and solutions that will be seen in all type of automation environment? First, first one is ignoring the bottlenecks. Next, unsequenced or poor path planning. And the last one is underutilizing the simulation tools used for regular practices. By considering all the three, it is understood that before going for any real time practical the production work, we have to see the efficiency of the various the production tasks or activities through by means of simulation software or virtual method. So based on that, we can somehow try to optimize the results by closely comparing with the real-time activity. So with the help of the simulation, we can change or reconfigure the work layout of the robotic assembly unit according to the user convenient. Now let us go with the case study. The first one we are going to discuss about the case study of single robot work cell layout. So this is the problem scenario that is given here. Let us consider a medium-sized electronic manufacturer. So their primary requirement is to automate the PCB assembly process with the help of the pick and place type of arm robot assembly. All the operation must be highly precise, well sequenced, repeatable in nature in order to handle multiple PCB variants. These are some of the common challenges that are addressed here. Each electronic components that are supposed to be inserted into the PCB board must be done with utmost care and accuracy. Every the PCB board are not belong to the same shape and size, so it may be vary according to the layout. So we have to add flexibility in tackling different kind of PCB layout assembly, and overall cycle time should be less than or equal to 45 seconds for each PCB board assembly, and all the operations are carried out within a small limited factory area. So these are the constraints that are given for single robot type assembly layout. And the solution methodology. So how to approach the solution methodology? So here are some of the few inputs that are given for solution methodology. So first thing we have to select which type of the, the robotic machines are required to perform the multiple set of activities on a given fixed area. So six axis type robot manipulator with high precision speed, specially integrated with vision cameras for easily locating the part moving over the conveyor. And flexible adaptive grippers that are kept nearby the end effector in order to handle various type of components which may differ according to the geometry. And special type of the force torque sensors that are mounted in order to check the part insertion during the assembly. And regarding the cell design, the conveyor, automated conveyor for feeding the part, and pallet racking system. Safety gauges has to be mounted through the surrounding area in order to avoid the collision or any sort of accidents. Here are some of the software, the control systems that are required for solving the single robot work cell type optimization problem. So this type of problem can be programmed using offline simulation software. For analyzing the vision-based pick and place calibration routines also, we can use the offline simulation software. And pinpointing any error in the production equipments. For that also, we can go by using simulation interface application in order to inspect or check the percentage of error present in the final end items. And these are the results that has been tabulated here by considering the following the performance metrics: cycle time, job accuracy, and uptime. Uptime means due to fatigue delay, that is waiting time, then wastage, scrap rate. So with reference to the manual production and automation, okay, so these are the comparison of results that has been given here. So these are the common takeaways with reference to the single robot work cell layout. Now, in comparison with this, we are now going to discuss about the multi-robot work cell type assembly system. So normally multi-robot work cell commonly used for mass production. When you go for large scale production, say consider an automotive assembly shop. So in that case, a multi-robot work cell is considered to be a preferable choice to perform all set of the sequential activities. So in this problem, there are three parallel the robot are considered. One for doing the part loading and unloading, another one for machining operation, and last one is for quality inspection and checking. And regarding the cell architecture, the arrangement of the cell architecture, initially the parts will arrive on a pallet system. So robot A will position the parts into the machining station, and next one will parallelly performing the machining process while the previous one will do the task loading of the next part, and the last one will do the quality check of the completed parts. So this is the workflow pattern of multi-robot work cell layout. All the three robots are synchronized together with the help of the program logic controller. And this is regarding multi-robot work cell, the output of multi-robot work cell by taking throughput, machining accuracy, downtime, as well as the quality rejection. comparing to the manual method and automation. Now we are in the final end of the presentation. Before closing the final presentation, I would like to give some of the common discrimination between single and multi-robot work cell. What are all the circumstances when we have to use? So depending on the following factors like complexity of the job condition, then regarding the cycle time requirements based on the part size and weight, the cost of production and the volume of production. Based on these factors, we have to select which type of the work cell layout is considered to be most affordable. And these are some of the common best practices which are applicable to both the type of work cell layouts as listed out here, uh, among which safety is considered to be one of the most common thing that has to be addressed on both single and multi-type robot work cell optimization. Now we are in the final conclusion of today's the research lecture, the presentation. Now I conclude that the choice of selecting either single or multi-robot work cell layout that is mainly based on the following the key parameters, say economic consideration, future scale of production, and which type of the product you are going to implement. So depending on these factors, we have to decide what type of the work cell layout that are mostly used primarily for doing automation related tasks with the help of the robot arm assembly. Even though there are many advancements in robotics with respect to sensing and other control techniques, but still multi-robot system is considered to be a more dynamic, highly challenging problem as compared to the single robot work cell on many industrial automation solution. So with this information, I end my lecture with a formal vote of thanks. I propose my formal vote of thanks to all existing researchers across the globe in the field of robotics and automation systems. Next, I thank all the PhD scholars and PG students who are doing their project in robotics application. Next, I thank my ex-co-workers and former HODs. Above all, I thank my family members for giving enough support during the tough situation in my career. Once again, I thank all the student participants, faculty members, and industry professionals. We will meet again in the next subsequent research lecture series. Thank you all.